This section leads to word problems that involve the trigonometry from the last section. I know how all of you love your word problems. Before we start though, here are some random facts. The average height of an NBA player in any given year is usually 6'6" or 6'7". Do you happen to know how tall the tallest NBA player was? And how short the shortest NBA player was? I used was in the last questions for a reason. They played a while ago, so this might be a bit hard except for the hardcore sports buffs. The tallest players were both officially 7'7", although in truth George is probably about a quarter inch taller. The shortest player of all time in the NBA was Muggsy Bogues. In the 1987-88 season, Manute and Muggsy actually played on the Washington Bullets together. And I happen to have their picture together too. That is a pretty crazy picture. It's just comical. Manute's knees are almost to Muggsy's waist. The top of his socks are the bottom of Muggsy's shorts. Manute's hands are monsters. I wonder when he could first palm a basketball. Manute's a stick too. He was 7'7" and weighed between 190 and 200 pounds. But I haven't gone crazy, at least not yet. There is a method to this madness. There is a reason why I have been leading up to showing this picture. It is a very good picture to show the concept of angle of elevation and depression. There are a lot of different meanings for the terms elevation and depression. This, surprisingly, is not a lesson on how an angle suffers from depression and something needs to come along to brighten its day. For this lesson we want to think about elevating something, or the opposite, where there is a big depression in the ground or something. What you need to think about when hearing the terms elevation and depression is the angle of elevation is going up and the angle of depression is going down. We will start with the angle of depression. Remember, depression is going down. Both angle of depression and angle of elevation start from horizontal. Somehow, some way, you need to remember that starting from horizontal bit. Will it help to see them do the wave? Or what if it changes colors? Will that help you remember? Somehow this has to stick, as it is the one thing students most commonly mess up with these problems. So here, guess what? We are starting from horizontal. Let's consider Manute here. He wants to look at Muggsy. He starts from horizontal and doesn't manage to see Muggsy at all. Clearly he is going to need to tilt his head down to look him in the eyes. So that's what he does. He tilts his head down until he is looking at Muggsy. From where he started, which was horizontal, to where he ended up forms an angle. That angle is the angle of depression from Manute to Muggsy. Now we move on to the angle of elevation. It is time to go from Muggsy's perspective. We once again start from horizontal. So Muggsy starts out by looking horizontally, which is a really unfortunate height to be looking. They probably didn't do a lot of slow dancing together. In order to see Manute's eyes, Muggsy has to look up, so he tilts his head up until he sees Manute's eyes. This also forms an angle. This angle is the angle of elevation from Muggsy to Manute. If you put Manute's angle back in the picture, you might notice that Manute's angle of depression and Muggsy's angle of elevation are alternate interior angles and are congruent. That's all there is to these two angles. Let's see them in action. A squirrel is on the ground and looks up at an angle of elevation of 38 degrees to see a lovely bird feeder in a tree that is 22 feet away from the squirrel holding a veritable smorgasbord for dinner. Approximately how far off the ground is the bird feeder to the nearest tenth of a foot? I know you love word problems. And the good news is that you often get to put your artistic skills to the test and you get to, yes I said get to, draw your own picture. So pause here if you would like to see if you can draw this picture on your own. We have a squirrel. He looks up at an angle of elevation of 38 degrees. But remember that angle of elevation always starts from horizontal, so put that in first. This is horizontal from the point we are starting from, which in this case is the squirrel. Now we can worry about the 38 degrees. The squirrel is looking up, so the 38 degrees goes here, and the squirrel has found a bird feeder looking in that direction. That bird feeder is hanging in a tree that is 22 feet away from the squirrel. The tree forms a 90-degree angle with the ground. The problem asks us to find how far off the ground the bird feeder is. This is the picture you should have drawn. Almost every single angle of elevation or angle of depression problem ends up with a right triangle as the picture. Once we cover section 8.5 and 8.6, then other types of triangles would be possible. But even then, for the most part, you almost always end up with a right triangle picture. Once we have this picture drawn, we simply apply SOHCAHTOA. For the 38-degree angle, x is opposite and 22 is adjacent, so we are talking about tangent. We solve for x and get this. Punching that into our calculator, and this is the result. The problem asks us to round to the nearest tenth, so this would be the answer you would finally put. Now it is time to illustrate the most common errors students make with these types of problems. Here we have a man working at the top of a lighthouse, and he spots a sailboat at an angle of depression of 17 degrees. The lighthouse is 112 feet tall. Approximately how far away is the lighthouse from the boat? Round your answer to the nearest foot. I hinted earlier what the common error was, so here it is. Students know they need to be drawing a right triangle, so they plop down the lighthouse that is 112 feet tall. We have a sailboat out here, and we need to know how far away the sailboat is from the lighthouse. They know a right triangle is involved, so they finish off the right triangle. Those parts are pretty straightforward. But what about this angle of depression? They know the guy is at the top of the lighthouse and depression is down, so they put in 17 degrees here. That's down. That seems like a good spot for it. But don't do this. It is wrong. Students constantly put the angle of depression there. The angle of elevation and angle of depression both start from horizontal. So we start with the man at the top of the lighthouse looking horizontally. The angle of depression is how far from horizontal he has to tilt his head down to see the sailboat, so the 17 degrees should go here. That's the correct spot for it. A hugely common error. At this point we have this picture. We have a lovely right triangle, but our 17 degrees is not inside of it. There are actually 3 ways to go about it from here. Option number 1 is to realize that the 17 degrees is alternate interior with this angle here. With that angle filled in, we then have the tangent of 17 is 112 over x. That's the first option. Note that the 17 degrees we filled in is actually the angle of elevation from the sailboat to the man in the lighthouse. Option number 2 is to realize that this part is a 90-degree angle. If 17 degrees is on one side, then its complement is 73 degrees. With that 73-degree angle filled in, we now have the tangent of 73 is x over 112. That's the second option. The third option popular with students is to build an upside-down triangle. They draw in pieces like this, and then copy over the 112 and the x. Now they have a right triangle with the 17 degrees inside of it. With a triangle like this, you also have the tangent of 17 is 112 over x. That's the third option. Use whichever method you like best. No matter which method you use or which formula you use, you should get that x is approximately 366 feet. This question asked us to round to the nearest foot. But this is the most common mistake students make. Always make sure you put the angle of depression in the right spot. Always start from horizontal.